All right. Yes, I'm Ethan Cradle. I'm here with Geocom. I'm a GIS project manager, uh, leading some of Geocom's indoor mapping projects. Also, been highly involved in a lot of next generation 911 projects. So, um, yeah, we'll go ahead and dive in. We're going to talk about indoor maps, primarily out of the public safety lens. So, a little bit about Geocom. Uh, we've been around for 27 years, specializing in public safety GIS. Company based out of Minnesota. I'm personally based out of North Carolina. Um, 17 statewide public safety GIS projects, and uh, really starting to specialize in indoor mapping with several different patents in that space. So I want to kind of start off by setting the stage with some statistics, and you'll see that some of these statistics were already referenced by some of the NCDIT crowd earlier this week, but um, just to rattle some of those off, over 80% of 911 calls are placed from cell phones. Um, Over 80% of Americans' lives are spent inside. We've got over 125 million buildings in the United States, yet less than 1% of those buildings have detailed indoor maps that are readily available to our public safety officials. So, uh, a 911 call initiated from inside a building doesn't actually provide that actionable location intelligence with regards to the origin of that call. Um, so essentially, that content with no context. And as a result of that, the challenge that's occurring is fatalities are the result. So as you can see here, the examples on the right are the Champlain Towers in Florida that collapsed. People were in those buildings calling 911, and first responders were having trouble locating them. So we'll talk a little bit about some potential solutions to aid in situations like that as it relates to vertical location services using X, Y, and Z axis data from your cell phones. So I want to talk a little bit about the indoor map development process, specifically Geocom's indoor map development process. So uh, made up of a number of different components here. A lot of it kind of fit into Geocom's indoor mapping engine, which has some patented technology behind it. So we've got that upload stage, what has to do with floor plans. So floor plans are one of the primary sources of data that we acquire from our customers to initiate that map build process. So then there's the analyzing of those floor plans, for instance. Is this data of high quality? Is it comprehensive? Is it accurate? Um, Making some yes no decisions, georeferencing that, and then kind of we have that patented technology that I talked about, which is semi-automating that conversion of those uh, JPEGs, PDFs, CAD files into actionable GIS data. So, our points, lines, and polygons. And then a pretty extensive QC process, which involves some additional attribution. Uh, One other thing I'd like to note on this piece is not everyone has floor plans for all of their buildings. So there is a on-site verification or data collection piece that can also be added to the sequence of steps as needed. We don't necessarily recommend or require going out and scanning every single building if we have a high quality floor plan. However, as needed, verifying floor plans and or performing that on-site collection is sometimes necessary. So after the indoor maps are developed, we actually publish that to Geocom's Public Safety GIS Content Library, and that is actually directly integrated with several different PSAT mapping applications. Primary example of one that likely everyone in this room's heard of is RapidSOS. So directly integrated inside of their RapidSOS portal. If we have indoor maps, those are visible on their map. So also integrated with Motorola's Vesta suite. Geocom has various mapping applications, and we're also in discussions with several other mapping providers to get that content into their dispatch maps. One other kind of final note on this piece is that the indoor maps that we're developing are conformant with the ArcGIS Indoors data model, as well as extended to encompass kind of the public safety industry standards, oftentimes defined by NENA. So a lot of those CLDSF elements that public safety backend systems need and rely on. So I want to kind of show you a few different scenarios of what floor plans may look like. If you've done, you know, likely all of us are in GIS, there's been a need for floor plans, digitizing in utilities. We may not have the CAD files, we may have to scan PDFs. So you vary in quality what you actually get from the end user. And as we see here on the left, we've got a pretty detailed floor plan, even all the way down to actually showing the lines on the basketball court, ingress and egress points, room labels. So very comprehensive, gives us a lot of information, appears to be drawn to scale. So what we would deem as an effective floor plan resource. On the right, not so great, right? We've got a warped image. We've obviously got some handwritten text. Lines are blurred. Not a lot of usable information here. So this would be an example of what we would deem as an ineffective floor plan that we wouldn't necessarily want to build a public safety grade indoor mapping data set with. So a few different components of indoor maps when it comes to like our floor plans, what we're looking for. We need a building footprint. You need room polygons, room labels, those exterior entrances, so that is ingress and egress points. And then on top of that, some additional kind of nice to have features would be things such as public safety points of interest like AEDs, fire extinguishers, camera locations, card readers. There's a high number of these assets that are of interest to public safety officials, so kind of prioritizing that and building in that into the design phase of these projects is a critical component to making sure that PSAPs have the information that they need, as well as first responders have access to this data. So we'll kind of tie into that. One other thing I want to touch on, it's in a future slide. I mentioned a little bit about what happens if we don't have floor plans. So there's been several presentations where LiDAR has been referenced. There's a lot of different LiDAR scanners on the market. Geocom tries out a lot of them. So this is just a few different examples of an image of a room with, for instance, our point cloud here, LiDAR scanner. And then this is a different technology here, different type of scan with an image drape over it. And as part of that, once we scan, as part of Geocom's conversion process, our end game is to develop that floor plan so that we can then convert that into actionable GIS data. So this would be an example of that. So this example here is an example of what an indoor map would look like. This happens to be in one of Geocom's mapping applications. However, like I said, this can go into any third-party mapping application for the most part. It's got all kinds of detailed information, points of interest, ingress, egress points, elevators, so on and so forth. It's also got a circled floor picker. So when that call comes in, leveraging some of the vertical location services that I'm going to touch on in a minute, it can automatically detect which floor that's on. So when the call taker answers that call, zooms into the map, we see the point of that call. It's already showing the right floor level, and they already have that actionable information for additional situational awareness. So some of that additional context behind that call. So this is an example of what a dispatcher may see. They may have building footprints or some additional layers, maybe satellite imagery, but essentially we've got a call, we've got the phone number, we've got a point, we have no context behind that point. When we add indoor maps, we can see how much more value that can add to the person that's dispatching that. So we can see here, oh, wow, this caller is actually in the auditorium. We already have a little bit more information about the situation, who may be on site, what we need to do to dispatch most efficiently. So then just kind of zooming in that area to the auditorium, you start seeing those public safety points of interest assets. So those are those additional nice to have features that I mentioned earlier beyond just kind of the typical bare bones layout of rooms, room labels, building footprints, so on and so forth. So for instance, if a call came in, someone was in that auditorium, and the call said, such and such isn't breathing. We've already got somebody trying to perform CPR while we can get dispatch out there. But we can also go ahead and say, okay, we see that there's an AED at the corner of the gymnasium. Run and go get it set up, and start that process while we're actively routing to that emergency. So you can already see kind of how that additional situational awareness of having additional content can save lives. So that's really what it's all about, is improving emergency response and saving lives. So this is kind of a more advanced scenario where you're kind of routing some of that indoor data. You've also got essentially what looks like a heat map on here. This is actually mapping devices, so devices connected to a Wi-Fi network. So, with this indoor stuff, smart buildings, various integrations, you can really take this to, a long ways to really get some very granular and actionable information. So, if typically we would access this building, for instance, from the north end, and we see, we've got all of these people congregated in this area, maybe that's going to slow us down getting in the building, so maybe we need to find a different route. So this is a little bit more on the future state, but possibilities are nearly endless when it comes to indoor mapping and the various prospects of leveraging the data. So if I were to ask a question in this room to say, in your opinion, which buildings are most important to secure? Likely you would say our schools and or this building, because we're all in this building. So when we start talking about large scale projects, we're finding that a lot of the first people to kind of adopt these indoor maps are public safety officials focused on where people are congregating. So these are convention centers, schools, large government complexes. So when we start talking about, for instance, schools, we have a lot of stakeholders. So I'm leading a specific project where we're mapping over 1,500 schools. When you start working with 1,500 schools, you're talking thousands of stakeholders involved. And when you start talking thousands of stakeholders, you're going to have a program built around what you're doing. So we're leveraging things like ArcGIS Hub for stakeholder engagement, information sharing about the program, access to training, leveraging an indoor mapping gateway. So this is a Geocom hosted site for actually gathering those resources for those projects, reporting and dashboards. Another key component, data-driven dashboards, right? We want to see the collection of the status. Stakeholders want to make sure projects are on time. They can see progress. They can report to, for instance, the governor or whoever, public safety officials as needed. And then obviously there's the web apps component of that. So specifically, we're going to be putting that in various hands of principals and school resource officers in the school, lens. And obviously there's the, when we're talking about data collection, leveraging things like field maps, as well as high accuracy GPS units for collecting X, Y, and Z data. So now I want to talk a little bit about indoor maps integration with vertical location services. So I talked a little bit about the problem, the Champlain Tower, of people calling 911 and there being a disconnect between where these people actually were and being able to get response out there to them to aid in that time of need. So before I dive into those weeds, I want to define dispatchable location to set the stage. So that dispatchable location is the validated street address or coordinates of the 911 calling party, plus additional information such as suite, apartment, or similar information necessary to adequately identify the location of that caller. So why is this dispatchable location important? On the map here, we see the call comes in. This looks like something you would likely see in rural North Carolina. Appears to be on a single tenant dwelling, maybe a shop, likely no more than 1 or 2 stories. We can send dispatch out there pretty easily and locate this caller without necessarily needing to have a detailed indoor map of this actual site. Now let's look at it out of a different lens. We're in the city. Maybe we're in Charlotte or New York City, Raleigh, where we have some lot larger complexes, or Winston-Salem, for instance. I've seen some larger buildings here. That call comes in, and let's say we're looking at the graphic on the left. When we look at the oblique, we realize this is actually a high rise with 20 floors on it. We know the XY, but we really don't have any way of understanding exactly where that caller is located, especially if it's a scenario where they can't talk, right? If all they have is, they can call 911, but, they're having a heart attack or whatever's going on, not being able to communicate exactly where they are poses challenges for our first responders. So that kind of Z-axis information is critical in situations such as this. So the FCC has passed various laws over the years, and one of which that's been passed across the past couple of years was the requirement for these cell phone providers to provide that X, Y, and Z axis data. So we've been getting X, Y. The Z axis data is also now a requirement for devices that are capable of providing it. So our smartphones. And obviously, depending on the smartphone, it's going to kind of dictate how accurate, right, that location that it's providing is. So unfortunately, the format in which that Z-axis data is distributed to these PSAPs is in the form of height above ellipsoid. Well, the Earth is not a perfect ellipsoid. We have mountains, we have valleys, we have hills. So in the example on the screen, we show the call comes in the situation on the right. It says it's 200 meters height above ellipsoid. What does that mean? Well, in the graphic on the right, it means that this is a single unit dwelling. It's likely on the first floor. Well, move down the street slightly, and it's actually in a little bit of a valley. Still 200 meters height above ellipsoid, but now we're on the third floor. So that's not really relative to anything. So what we need is height above terrain. So that's kind of one of the other patents that I reference as part of, one of Geocom services, actually that conversion of height above ellipsoid to height above terrain. And that can leverage several different data sources, digital elevation models. So it could leverage publicly available data sources like digital elevation models, building footprints, or locally authoritative data, which would likely be even more accurate than, for instance, like a 3-meter DEM. So that was the problem and the solution that Geocom's working to solve. So as you see here on this map, it's a great graphical representation, but really the bread and butter of what the dispatcher needs is what's in text. The building address, name, height in which the caller is located, and the estimated floor. So depending on that underlying source data is going to dictate the accuracy percentage for us rating where that call is. So in this scenario, we're saying that this caller is located approximately on floor 19. So when we kind of combine that with the indoor maps and we're mapping out facilities, we have a better idea of the height between floors. So then those estimates, we get higher accuracy estimates for this. So a lot more context behind the calls coming in. So a lot of information there, how we're leveraging indoor maps to support public safety, how it can benefit schools, convention centers. There's been a lot of talks about indoor maps and using it for asset management and space planning, and it is a really fascinating piece of GIS that is making a difference in the world, right? So that covers everything that I have for today. Does anybody have any questions?
So I have a question on when you talked about kind of future state of routing. So I was wondering how much of like interior routing are you guys actually doing or providing? Second, like how are you dealing with things like stairways when there's hallways and so on? Like say an emergency response plan is put together, they show stretcher with someone's responsive. They get there and they can bust in the door, just only find out there's a huge flight of stairs. It's not an emergency route. I'm just kind of curious.
Okay. Yes, I mean, we are mapping each floor, right, so they can see what's going on with each floor. The data is built to be routable. So as far as being route in and out of doorways and hallways, um, as well as uh, for instance, like a school campus, you've got we are incorporating things like emergency operation plans. So things like reunification areas, um, uh, various different assets uh, for to aid in those states of emergency, and as well as to aid in operating annually those emergency operation plans. I believe that there was an escalator on one of the other slides. But as far as like the 3D capabilities of it, a lot of what we're doing is more so two-dimensional to not overload those PSAPs, right? There is such a thing as too much information, whether we actually want to agree with that or not. But in the state of an emergency, when that um, call comes in, they want to be able to have as much information to make the decisions as fast as they can without being overloaded and without having to take additional time to open up additional screens to see 3D. And so efficiency is really what it's all about when it comes to 911.
Other questions? How many folks are actively thinking about doing this kind of thing, like having to charge the task of having to provide maps to allow folks to respond quickly to an incident happening?
All right. Well, I'll be around the rest of the conference. Feel free to hit me up with any additional questions, and I'll answer as able or direct you to someone that can.